Hello and welcome everyone. We're really excited to have you here today for our weekly OCI deep dive. For those of you who may be new to our events, we're hosted on Cloud Customer Connect or Oracle Community Forums for end users. I'm Catherine Jennings, Senior Principal Product Manager, and today we're joined by Derek Harlow, Senior Product Manager, to take us through tips for managing database management of cloud databases. Go ahead and take it away, Derek. Thank you.
Great. Thank you, Catherine. And let's go ahead and get started. So we'll first talk about the observability management overview, kind of the parent organization for our monitoring capabilities. So the observability starts with our basic cloud control services like compute, storage, networking, and security, control plane telemetry. And from that, we've built a set of foundational services like monitoring, logging, notifications, streaming functions, and resource manager that help accelerate and protect cloud-native app development. And we've developed a service connector hub so services can observe, manage, and integrate with other Oracle services as well as with open standards and third-party services. And on top of that foundation, we continue to add advanced services providing capabilities that help you gain greater insight, solve current business problems, and innovate for the future. With the Oracle Cloud O&M platform, the hard part is already done. Simply add services that work in context with each other as you need them, and they'll share common functionality and resources rather than having to code all of the items individually. Oracle's solution employs a unique integrated approach that provides organizations with end-to-end visibility, predictability, and insights across all layers of the technology stack deployed in both the cloud and on-premises. Oracle brings a holistic approach to a multidisciplinary field where existing solutions are piecemeal and fragmented, requiring companies to dedicate significant staff and budget for integrations, the infrastructure, and the maintenance of all of these. So Oracle eliminates the complexity and risks associated with today's multi-tool approach to make multi-cloud management intuitive and effective. Today, we'll be looking at a little closer into the database management operations insight services and how they can provide a great value to managing your cloud databases. Oracle's observability and management services are integrated services that provide a complete management solution to help meet your manageability challenges running on-premise, the Oracle Cloud, and other vendor cloud environments. These integrated services are built upon each other rather than just a bunch of different or non-integrated cloud services existing to serve their different applications. Because these services are integrated together, you no longer have to guess, spend time on, or resources on trying to figure out how the applications are performing. These services provide focused monitoring and management of the Oracle database running in your on-premises data center or in the cloud. Database management provides comprehensive management of databases for all flavors of Oracle databases with its full lifecycle solution encompassing monitoring, performance management, tuning, and database administration. Stack monitoring focuses on monitoring the Oracle databases and its surrounding ecosystem, including its components such as listeners and ASM, as well as the host the system runs on. The application and application servers that it uses, and it enables you to have a 360-degree view of where and how the database is used. Logging Analytics monitors and analyzes log data on Oracle databases and surrounding system infrastructure, enabling you to troubleshoot errors based on log data. Operations Insights enables you to trend and forecast database resource requirements and analyze SQL performance problems across your entire fleet of databases. Today, we'll be focusing on the database management and operations insight services to focus on proficiently managing your cloud databases. In terms of database management, it is an on-demand cloud-based subscription service that is natively available in Oracle Cloud Infrastructure as a managed service. It combines the back-end instrumentation and tools that are already available within the Oracle database kernel itself, and you have rich visualization-driven interface providing a single pane of glass management console for databases that are deployed either in the cloud or on-premise. Now, Oracle databases deployed in the cloud could be on OCI virtual machines, bare metal, Exadata, or autonomous databases, and you can have cloud-native capabilities which allow you to have continuous upgrading and patching of the tool itself. You don't have to invest time or resources to manage any agents, data, or the monitoring solution. It allows you to have true cloud elasticity where you can lower your operational costs. The features comprising the service are designed to minimize efforts in the monitoring and administration of your database fleet. A unified view for managing all of your Oracle databases across on-premise and the cloud provides quick insights into overall performance and short-term resource trends of your databases. Performance diagnostics are provided with integrated views of database activity. Drilling down into a single resource homepage offers an overview of the performance. The ability to launch Performance Hub allows more detailed performance analysis, which includes Ash analytics, blocking sessions, ADDM reports, and top activity light. Administration tasks like table space management, parameter configurations, the SQL Tuning Advisor, Optimizer stats reports, and SPM, and more are available in the resource console. So first, we'll be looking at the key features in Database Management Service. The Fleet Overview allows you to see all of your database resources in a single pane of glass view. You can quickly assess database resource utilization, as well as perform trend analysis based on historic performance. Metric and event alarms are displayed for your resources, and the ability to drill down into a specific database provides a vital workflow to mitigate any performance or availability issues occurring within your database fleet. As cloud deployments continually scale to address your needs, the Fleet Overview will become a valuable tool to assess overall performance for all of your databases. You will quickly be able to find outliers in performance or spot databases with excessive growth trends. From here, you can drill down to resource-specific pages to continue investigation on a more granular scale. PDB support is now available for cloud databases. This includes any database version 19C and above in the cloud or 12C and above for external database resources. Capabilities previously allowed only on CDBs are now supported for PDB resources, including Fleet or single database level features. Cloud PDBs will be included in the Fleet summary, and you can create database groups with PDB database resources or filter based on database type. If you are familiar with the Enterprise Manager, you likely have seen the Performance Hub before. You can obtain access to real-time monitoring utilizing Ash analytics, SQL and session details with information regarding blocking sessions. Historic views can also be adjusted for longer-term performance investigation. You can launch other service features like ADDM on-demand reports, SQL Tuning Advisor tasks against specific queries, or more in-depth SQL investigations with SQL monitoring application. Traditionally, Exadata AWR statistics can be difficult to digest quickly. It takes expertise and experience to assess the wait events and I/O statistics. Depending on configuration, multiple AWR reports would be required to get a full picture of Exadata resource usage and can increase time to recovery for system performance. The new Exadata Tab and Performance Hub resolves these problems. You no longer need to generate multiple AWR reports and look through the tables to find the pertinent outliers. Visualization of the metrics have been provided to quickly assess the overall health of your Exadata system. You can check I/O metrics for read and writes on cells or individual disks. The top consumers can be seen within the details to find any databases that might be monopolizing the Exadata resources. And finally, you can view configuration of your storage servers as well as the ASM disk groups. So it is a valuable tool to utilize whenever you have multiple databases running on your Exadata fleet. When generating an AWR report, the wait events are summed up and averaged to show wait times for the entire window. You can see the report showing total waits and average wait time in the report. When looking into performance issues, it can be difficult to narrow down the exact snapshot intervals to investigate to find the root cause. Sure, average wait event metrics are useful to show how a wait event was performing between snapshot intervals, but what if your elevated wait times only happen for a smaller portion of the overall window? You're going to lose granularity of your performance metrics. The overall wait time average is going to be reduced when the system was performing as expected. Here, the control file sequential read and wait averages are displayed for two separate snapshot intervals. The first is for a single hour within the larger performance window, let's say between snapshot intervals 2 and 3, and the second is a longer period which encompasses the first snapshot interval, snapshots 1 through 4. You can notice the difference in the average wait time, but this only happens if you generate multiple AWR reports and examine each separately. Is there a better way to go about this? Of course. AWR Explorer provides you with a graphical visualization of the most important AWR statistics and will enable you to perform advanced diagnostics of AWR data. A graphical chart reduces this average wait event problem and allows us to see spikes and patterns by keeping the individual AWR snap granularity exposed over a longer period of time. It is easy to see performance trends and identify patterns by selecting longer time ranges without generating a large number of AWR reports and toggling between them. Short snapshot intervals have always been preferred when trying to identify an issue, but it has also been difficult to maintain because of the amount of data to digest. By presenting several graphs on a page and providing the ability to remove less impactful event graphs, it helps narrow down the problem and see correlations between the wait events. Wait time on certain metrics could be correlated with another metric. Increased amount of login may result in higher wait times on CPU or I/O. If there is a certain pattern or a certain event that may be of interest, then it will be possible to drill down by generating AWR reports or ASH reports or even SQL reports from within the AWR Explorer tool itself. The AWR Explorer generates top activity from your AWR data, allowing a familiar but convenient tool to begin performance investigations for past time periods. You can quickly find elevated wait events and drill down to additional tabs within the Explorer to gain in-depth data around the database metrics or wait events for the periods you have selected. The AWR Explorer has a tab for metrics and will show data from the DBA HIST metrics history table. We provide a set of default metrics like average active session, CPU, I/O, network, and logons to get started with. And there's also a set of graphs not displayed, so if you want more data, you can select the metric and add the charts to the console. In the same way, it's possible to remove a chart if it is of no or limited interest in your investigation. And of course, it inherits the time dimension selected from the previous tab to keep your reference during the investigation. The Load Profile tab provides system-level statistics from the DBA HIST tables shown here. You can also get additional database metrics such as time model overview, connections, or logon information to correlate any specific wait event spikes during the time period. And finally, the Wait Event tab depicts top wait events for the selected snapshot intervals. In this tab, we show the top 10 wait events sorted by the wait time. For each tile, there are two values: the average amount of waits per second and the average wait time. As in all graphs, it inherits the time dimension. One thing with wait events is to understand how long they are. If we are talking about microseconds, then it has minimal impact on the user experience. But if we are talking about both milliseconds and even second longer waits, then it may be impactful to the user experience. We are therefore providing a graphical histogram for each wait event. We divide waits into different buckets. Each bucket is twice as long as the previous bucket, and we provide the amount of waits that fit into each one. In this example, most of the waits are around 500 microseconds, but we have two waits that are up around 8 milliseconds, or that are around the 8 millisecond mark. So this can help us understand why some users may complain about bad performance, while others have no problems at all. It also can help diagnose intermittent problems during the interval to provide a more granular picture of performance in between the snapshots. Top Activity Lite provides a less resource-intensive view of real-time activity. This allows quicker refreshes of current performance, even when the database is impacted by a heavier application workload. You can adjust the data source between database memory or the memory and AWR data. There is a refresh interval, which you can toggle, and you can drill down on specific sessions or SQL statements to gather additional details for investigation into performance problems or perform root cause analysis. SQL monitoring is also available from within Top Activity Lite. You can invoke the SQL Tuning Advisor to run against the selected SQL statement within the console itself as well. There's a time zone selector, which allows you to analyze data on the database time zone or browser time zone. A slider is available to gain SQL and session information for the selected time period. From here, you can utilize additional performance tools such as SQL monitoring or SQL Tuning Advisor. In SQL monitoring, you can quickly find and sort the largest consumers for the selected 5-minute interval based on execution time, I/O, or database time. You can view query execution in real time to track expensive operations in order to triage performance tuning in your database. SQL Plan Manager allows database users to maintain stable, optimal performance for a set of SQL statements. And SPM functionality can be managed and configured to improve the overall performance of database environments over time. The new SPM feature in database management allows visualization and deeper insights into the usage of SQL plans utilizing the following capabilities within the database resource homepage. You have an overview of the SQL plan baselines in your database. You can filter the SQL plans by usage or statistics and search based on SQL text, plan name, or origin, whether it's auto origin or manual capture. You can configure retention and storage budgets for SQL plans, enable automatic plan capture with filters based on SQL actions, module, parsing schema, or SQL text to be more granular in your collections. And you can enable and configure the automatic SPM Evolve Advisor tasks. Here's the current supported deployments within the database management service. A couple of notes to call out is the ADB roadmaps. We are currently working on the advanced features, but we do have some of the basic administration features available now. You can see with BaseDB and Exadata dedicated, as well as the external on-premise, we have full capabilities. And then our XSCAC monitoring deployments are on the roadmap as well. For cloud databases, we do have two options, the basic and full management options. The difference between the two is for basic, it is free of cost. You can enable it today. You do get the Performance Hub, which provides the Ash Analytics and SQL monitoring tabs. We will note that this is CDB only. PDB level support is not included in the basic management. And you also get 14 key metrics for the CDB. Now, the full management provides you all the capabilities of the basic with additional features, such as the database fleets. You'll have the summary. You'll get all of the tabs for Performance Hub, which includes Exadata monitoring and blocking and ADDM. You'll get the rack monitoring, the SQL Tuning Advisor, as well as other database administration features. And finally, the support for the PDB is included here. Quick workflow for enabling the database management for our cloud database resources. You'll notice that on the database homepage, you will have more information. The associated services will be listed here, and you can click on the Enable button, which will bring out a workflow to enable. You can provide the cluster, the home, and the name that you're enabling for, and then you will also need to input the service name, the protocol, and port. Then you'll need to specify credentials for the connection of the monitoring user, the private endpoint that is going to be utilized, and here's where you'll select either the full or basic management to enable. Once you have selected, you can click the Enable Database Management button, and you should be able to utilize the service. Next, we'll be discussing our Operations Insight service. Traditionally, performance management has utilized recent data to investigate and triage issues within the database. Workflows generally start with launching Performance Hub to view average active sessions for your database and checking for any spikes in wait events or other anomalies. From there, additional reports such as AWR or ADDM provide granular data for root cause investigation. Finally, invoking SQL Tuning Advisor for ADDM or ADM for recommendations for improvements can assist in quickly mitigating issues. This can be a long process that requires hours of searching and investigating to find what might have been the root cause. How can we break this reactive model and take control of our database health and performance? Today, performance management is focusing on proactive solutions to prevent such performance issues. Being able to stop a problem from even occurring is the best case scenario to provide healthy, performant database environments. The Operations Insight service provides many advanced monitoring and reporting capabilities for your entire enterprise. Data is stored for 25 months, allowing deeper insights into the performance and trends for your environments. AWR Explorer and ADDM Spotlight provide new ways of consuming and interpreting diagnostic reports for your databases. The SQL Warehouse and SQL Insights explore long-term SQL performance metrics to provide trends across your database environments for specific SQL statements. Capacity planning forecasts critical resources for your database and host resources to prevent unexpected bottlenecks or provide assistance in consolidation of environments. Finally, the AWR Hub, EM Warehouse, and Exadata warehouses are repositories providing a lakehouse for telemetry from various sources accessible for deep operational analytics. You can create customizable reports or user-driven analytics within these data stores. ADDM Spotlight provides visualization of ADDM findings and recommendations generated from the AWR snapshots configured for the database. Aggregations of findings and recommendations for each ADDM report are shown on a timeline to provide quick analysis of trends or chronic issues in your environments that might have gone unnoticed. Tabs display findings or recommendations tables sorted by impact to the environment to assist in triaging performance improvement tasks. Exadata Insights is a single pane of glass overview for your entire Exadata fleet. Top resource utilization for your Exadata fleet is displayed, with trends allowing you to assess infrastructure needs. The trends are generated on historical usage over the previous 25 months. You'll be able to see all Exadata systems within and their configuration details, their current resource utilization, and then forecasted resource utilization. The insights will assist in estimating future needs for your environments. Either consolidation or scaling may need to be considered to maintain the overall performance of your Exadata fleet. As just mentioned, the insights can be utilized in consolidating the databases within your Exadata fleet to reduce costs for your infrastructure. Individual Exadata system details show the resource utilization trends. You can drill down to view top consumers by databases or hosts, and the tree map views of the top consumers within a system quickly depicts the fastest growing resources and trends of their growth based on seasonality trends. SQL Insights provides key performance metrics for your SQL statements across your entire enterprise. You can view statistics based on how a SQL ID is performing across many databases. For example, if you have several hundred databases running the same application, you'll be able to see performance for a single query against all of the databases. This allows in-depth monitoring of your performance and allows tuning at scale to give the most benefit when performing tuning tasks. Currently, SQL Insights is built upon the OCI dashboard framework, providing capabilities that can be customized for depicting the SQL analysis in your fleet. The SQL Explorer is an application which provides access to the SQL warehouse data. The intuitive query building design allows you to generate graphs built of your own custom queries against the data store. You can customize your performance reports and build widgets to integrate into the OCI dashboards. So here's the support matrix for the deployments within the Operations Insight service. So you can see the main features we have here along with their supported deployment types. So next I will go into a demo of our features here. So logging into the OCI console, you go to the navigation menu at the hamburger. You can see the Observability and Management platform here. Within this, we have all of the discussed services, logging analytics, the application performance monitoring, database management, operations insights. So we'll focus on these two today. Quickly going into the console for the overview, you can see how many databases you have enabled and how many databases are being monitored. And so going into the fleet summary, some of the key features here, currently we're looking at all of the databases within the compartments, but that can be adjusted if you have a database group. So if you have specific application databases you want to group together, or if you manage only a few databases within your compartment, you can create a group and monitor those through that means. You have a quick summary for your inventory, your status, resource usage, and alarms for databases within your view. And you have a time period selector, so you could select the last 60 minutes. You can go to the last 24 hours or the last 7 days. And we also have a comparison built in, so you can look at the same 60 minutes yesterday, the same 60 minutes last week, and use those for comparing how your resources are being consumed on your databases. So going down to our table, we can quickly see our databases here with the most average active sessions. And then we also can see how they're trending as well with their comparison period. So the same 60 minutes yesterday, we're looking at a reduction in average active sessions of 13%. So this is pretty handy to be able to see which resources are changing, which ones are consuming the most resources within your fleet. You can also go to the Performance tab, which provides a tree map view for your resource consumption. Right now, we are looking at database time. And so the size of the boxes here with the resources indicate how much DB time they're consuming. The color is indicating actually the change of the resources in your comparison period. So you can quickly visually assess which environments are growing at a more rapid pace as compared to others. So we can see some of them with the most active ones is actually one of the smaller databases. It looks like the change has been 600%. So if you want to drill down into a resource, you can quickly find out what might have been changing and assess if it's IO related to perform some tuning operations or some other similar things to that. So you can drill down into the database from the fleet overview, and you will quickly see a summary of your database with some additional details here, such as version, the compartment they're located in, as well as instance status and connection. And then you'll be able to see a timeline for your monitoring here, where you can hover over and see how your database is performing. You have the top summary of your resources here, so you can see average active sessions quickly, as well as any CPU, IO, memory, or storage utilization metrics as well. Again, you can select your time period analysis to hover between the last 60 minutes, 24 hours, and 7 days. We do have capabilities of viewing the alert log here. If you do have any issues, you can filter them. You can search by criticality and do some additional functionality here. One of the newer features that I had discussed earlier was around our SQL plan management. So here we can see our SQL plans available within the database with some additional metrics around those. So we can quickly see the summary of the databases. So we currently have 108 SQL plans enabled for the database. We have the automatic capture enabled for this database. And then we also have the automatic SPM Evolve Advisor task enabled. So this should choose the better performing plans, add them to our SQL profiles, and enable them for the optimizer to choose the best execution plan to access the data within the database. We can quickly see the baseline last executions here, as well as some SQL plan statistics as enabled, disabled, fixed, or accepted, with some additional details here. So we can actually filter our plans based on the execution, and we can even filter them based on being enabled. You can go down, you can see the SQL text available with the plans, you can see the plan name, and then you can get some additional details. So you can edit the SQL statement attributes here. If you wanted to auto purge, enable, or fix the plan, you could do that in this pop-out menu. And then you can also go to the individual SQL plans within the SQL database to view the details for the plan. So here you'll be getting general information about the plan, about when it was created, when it was modified, what some of the values are for the SQL text itself. So you can see the handle, you can see the SQL text, you can see the plan name, and then you can even see your execution plan for it. And finally, you also have your predicate information for your filters. Going over to the next tab, you can actually load SQL plans manually. You can either do it from AWR or from the cursor cache. If you wanted to load from AWR, if you have a better performing plan in the past that's maybe no longer in your buffer cache, you can select the snapshots that you want to bring those plans in from. And then you can even filter based on your SQL text that you want to bring those plans in. For the configuration of your SPM capture, you can set retention of up to, I believe, over 400, 500 weeks to retain those plans. And you can set a space budget as well, so you're not overrunning your database with plan details. You can set the automatic plan capture. And so if you want to filter out the plans you are capturing, you can do that here. You can include and exclude. You can select it from specific modules or parsing schemas. So you can be very granular in how you're capturing the performance plans that you're going to be implementing. And finally, you can do a similar configuration for your automatic SPM Evolve Advisor task. Going back to our fleet overview, I will be going into our performance hub. As I said before, if you're familiar with EM, then you'll be familiar here as well. We do have some additional tabs though, the Ash Analytics, SQL Monitoring, ADDM, Blocking Sessions, and Exadata tabs. So you can see the SQL Monitoring, you can see your queries running on your database in real time. So the status of them currently executing versus finished. And you can also sort on database time. So if you want to see the SQLs taking up the most time, you can also do this on duration. So if you want to find any long-running SQLs in your database and address those at that time, you can. You can select the SQL ID to get more information on this and to open up the SQL monitoring for the specific SQL query. And this should bring up additional information around your plan statistics, the SQL text for your SQL execution, as well as your SQL bind values. You can view the activity based on active sessions that it is running. And finally, you can get metrics for the running of your SQL statements. You can also choose a graphical explain plan here to view this in real time, and you can get additional information on how these operations are running with some additional cost analysis here. And then the color indicating how it's performing between each plan execution. And finally, I will go into the Exadata tab as well, where we can see some additional details around our Exadata system. So here we will get a summary around our I/O for our flash disks, hard disks, and then within all of our requests around our CPU as well and their disk utilization. And going into the Exadata details, you'll be able to get those in-depth AWR metrics here. So you can go into the health of your storage servers, see any open alerts or disks that might be offline for specific storage servers. You can run or you can view ADDM reports pertaining to the Exadata system. This is a very valuable tool here to see your top consumers of your I/O for your storage servers on your Exadata system. So you can quickly see that the CDB database is really the top database consuming the most I/O. So then you can kind of go from here, kind of drill down into that database and view additional details there. You can see your cells and how they are performing, flash disks and hard disks, looking for any outliers in the I/O latency that you might need to address. And then you can see individual disks as well, again, looking for any performance outliers that you might be seeing, any hotspots, overutilized disks, or anything along those issues. Next, I will be going over to our AWR Explorer to quickly show some of the capabilities there. So one of the interesting things about AWR Explorer, or not interesting, but one of the handy things that you can do here is you can actually load AWR snapshots from other databases into here. It will recognize those and you can select them to view them within AWR Explorer. So if you don't have it currently enabled, you can go load the snapshots into AWR Explorer, and then you can perform your analysis here. So I'm going to adjust our time here. And here we can see the load profile for our database during this time. We have the time model overview, connections, logons, additional information here. We can remove a chart if we're not interested in it, or we can also bring it back by having some custom charts or those charts out of the box. We can add those again. We can go over to our metrics and see similar metric events. So we can see our logons, our IO requests, and we can really paint a picture of how our database is performing during this time. And we can visualize those AWR metrics instead of having to scroll through the long lists of text and kind of manage those. So here in this situation, we can see very quickly that there are some outliers here. We do have direct path read temp. And so these wait events are kind of the top wait events in the AWR report, and they're going to be displayed here in the same fashion. And so we can load additional wait events if we want to, but one kind of thing that is apparent here is if we look at our direct path read temps and our DB file sequential reads and our direct path write temps all during this time, it seems like they started having average wait time spikes. And so we can actually zone in and kind of narrow down our scope. All the charts are going to be changed as well within our wait time. So if we look at a histogram for this time period, this one looks like it's pretty much baseline normal database activity. We can see our categories here, 4 milliseconds, 2 milliseconds. This bell curve is nice, good distribution. But if we come over here and select one of these time periods, we can see that our histogram has kind of shifted over quite significantly, actually. Whereas we were seeing it here, sometime during the snap interval, we were having excessive waits, looking at half a second waits, which is 400 or 500 times longer than what we were seeing before. And so this is reflected upon multiple wait events during this time. And so then we could generate additional reports all within this time, look at different load profiles, but then drill down even further to see what exactly was happening at this time. Next, I'm going to go over to our deployments for our operations insights. So this service is really going to be focusing on the capacity planning, fleet level monitoring capabilities within our fleet. So if we go into this overview page, we should be able to see all of our resources, CPU, storage insights, memory insights, and we're looking at how these are trending and capacity forecasts for an extended amount of time. So our time range currently selected is 30 days. So we're going to look at previous 30 days performance, and then we're going to forecast the next 30 days, how we are going to end up at that time. And so this is the entire fleet overview of our resource usage. And then we can see our CPU looks like it's going to be dropping 5% in the next 30 days. Storage is going to be going up 30%, memory 45%. So each individual category we can look at further for CPU insights, storage insights, and memory insights. Really find which databases are going to be moving from high utilization up into our grouping of greater than 75% CPU usage. So 6 of them are going to be growing, and it looks like we're going to be staying the same on the lower side. We can find our top consumers here, and then we can even go down and check out which databases are expected to grow rapidly, and then look at the forecasting trends based on machine learning to look at seasonality for our resources. So we can add our max usage forecast because our resource usage needs to hit those high levels that we're expecting. So utilizing this, we can kind of forecast into the future what we're going to need for our databases to perform adequately. Similar configuration within our Exadata systems. We can go in and we can see for our fleet of Exadatas how they're performing and what our expected resource utilization is going to be. And we can see it all in one single location. So right now we have a few racks out here, and we can kind of see the distribution of our inventory based on their size or the type. And then we can see which resources are going to be utilization or hit utilization estimates and how much time we're going to be out until then. So this rack here looks like we have our utilization of 75% threshold. It's over that by 5%. So now it's saying, hey, we really need to look at this rack, maybe consider adding resources or moving some of our databases off of this rack. So we can see that our memory is a little high, not close to the utilization, but our CPU is our main issue here with this rack. We can drill down to see the metrics by individual databases. And so we can kind of get a tree map view of our top consumers, find which ones might be growing the most, might be consuming the most CPU, and kind of start working on which ones we're going to migrate off the system to free up some of those resources for our other databases. Similar, we can see metrics by the host. So we can see the two hosts, and then we can see trends and forecasts for those as well. So maybe if we're running certain workflows on one versus the other, we might be able to swap some of those things around to better plan for the forecasting there. And finally, we can go into our Exadata storage server metrics, again, looking at the forecasting and then our estimates on when we're going to hit capacity for our operations here. So we can see the throughput for our storage servers as well as their rates. Okay. And then we do have the SQL warehouse capabilities here, as I was discussing earlier. Just quickly show the consolidation of our SQL performing statements and kind of some of the analysis with wait times, grouping the inefficiency or plan changes for our SQLs. And then we also have this integrated into our SQL Insights dashboards. So we'll be seeing this data kind of consolidated there as well. But you can kind of drill down into inefficient SQL statements based on their plans. You can see how they're performing across multiple databases. And then you can even drill down into the individual statement to gain more data based on the metrics, your performance trends, the response times, etc. And then you can compare your plans and how they're performing on either the database or the two execution plans themselves. So you can see kind of a spike increase in this specific database, and you can address those at that point. And then you can compare the plan details for those as well, which looks like I went to a different one than common. Okay, and so customers have the different monitoring and management needs, and Oracle differentiates itself by providing customers with the choice of services and solutions. And when the customers actually make a choice, it's not yet another tool or different source of truth. It's part of an integral platform with scale, extensibility, and includes years of management experience in the latest technologies. Again, we want to bring that built together rather than bolted on needs for our solutions. And so here's the resource slide. If you would like to learn more about our services, we do have some videos out there for database management, operations insights, as well as some blogs covering a lot of our features. And then we do have hands-on labs there where you can actually get hands-on with the services themselves and kind of work with them if you have not done that before. Thank you all for joining.